Good morning, sir. My name is Sri Harshita. I am from CSM. Now I am telling about implementation of constraints for CIA 2. My topic is implementation of key and integrity constraint of them. First, we discuss about introduction to key and integrity constraints. Key and integrity constraints are essential for maintaining data accuracy and consistency. They are crucial components in relational database management system. In short form, we call it as Dbms. Understanding these constraints helps in designing robust databases that prevent data anomalies. Now we discuss about types of key constraints. Primary keys uniquely identify each record in a table, ensuring no duplicate entities. Foreign keys create a link between tables, establishing relationships that enforce referential integrity. Unique constraints ensure that all values in a column are distant across the dataset. Next, we discuss about primary key implementation. To implement a primary key, a database designer must designate one or more columns as unique identifiers. Most RBDMS provide options to ensure primary key constraints during the table creation. Attempting to insert duplicate values into a primary key column will result in an error. Next, we discuss about foreign key implementation. Foreign key implementation involves establishing a link between a primary key in one table and a foreign key in other. This creates a parent-child relationship that helps maintain data integrity across related tables. Cascading actions can be defined to automatically update or delete related records, preserving referential integrity. Next, we discuss about unique constraints. Unique constraints can be applied to one or more columns to ensure all values remain unique. They can be implemented alongside primary keys or independently to ensure additional data integrity rules. Validating a unique constraint will prevent any insertion or updates that create duplicate values. Now we discuss about check constraints. Check constraints are used to enforce domain integrity by specifying a condition that must be met for each row. They can be applied to individual columns or to multiple columns in a table. An operation that inviolates the check constraint will result in an error, ensuring data validity. Next, we discuss about not null constraints. Not null constraints ensure that a column cannot contain null values, preserving completeness of data. They are often applied to essential fields that must always have a value, m- such as a ruler ID or email address. Attempting to insert a null value into a not null column will trigger a database error. Implementing constraints in SQL. SQL provides a straightforward contains for defining constraints during table creation or alteration. Constraints can be added using the table creation command or modifying with the alter command. Proper implementation of these constraints are crucial for maintaining the integrity of the databases. Constraints can be specified when the table is created with the create table statement or after the table is created with the alter table statement. SQL constraints are used to specify rules for the data in a table. Constraints are used to limit the type of data that can go into a table, which ensures the accuracy and reliability of the data in the table. If there is any violation between the constraint and the data action, the action is avoided. Constraints may be a column level or table level. Column level constraints apply to a column, and the table level constraints will apply to a whole table. The following constraints are commonly used in SQL. Not null constraints ensures a column cannot have a null value. Unique ensures that all values in a column are different. Primary key, a combination of a not null and unique. Uniquely identifies each row in a table. Foreign key prevents action that would destroy links between tables. Check ensures that the values in a column satisfy a specific condition. Default sets a default value for a column if no value is specified. Create index used to create and retrieve data from the database very quickly. Next, we discuss about the benefits of using key and integrity constraints. They help prevent data anomalies, ensuring that the data remains accurate over time. Constraints also streamline data retrieval process by maintaining consistent relationship between tables. By ensuring data integrity, they enhance the reliability and quality of the database system. Next, we discuss about the conclusion of our topic. Implementing key and integrity constraint is vital for effective database management system. Understanding their application helps in creating data tables that are both efficient and reliable. Ongoing education in database design will facilitate better implementation of these critical constraints. Thank you, sir.